Okay, so today we are going to talk about tracking data lineage with Neo4j and Linkurious. But first, let's start with a quick introduction. So my name is Jean Vidieu. I'm a co-founder of Linkurious, where I am in charge of sales and marketing. We are a small startup based in Paris, and we specialize in graph visualization. So what is graph visualization? So first of all, a graph is a set of nodes and edges. And here we have a concrete example. And I can see two persons, one here, another one here, and they are both linked to a location. And as we are in a property graph, these different nodes have properties. So, for example, the person on the left has a name, which is Seb, an age, which is 29. The person on the right has a name, which is Jean, and an age, which is 31. And they are both linked to a location, which is Paris. So, to reiterate, here we have a node, their relationship, and there we have a property. So that is what we call a property graph. And graph visualization is a technique which consists in looking at the data as a graph. Today, as I mentioned, we are going to talk about data lineage. Data lineage is defined as a data life cycle that includes the data's origin and where it moves over time. It describes what happens to data as it goes through diverse processes. So it's very simple. It's where the data comes from, where it goes, and in a highly organized organization, it can be very simple, very elegant. The only problem here is that, of course, in the real world, a real-world data pipeline looks more like this, like a spaghetti plate where everything is mixed up together, and it's very hard to know where a particular data point is coming from, what processes it goes through which systems it goes through, and that can result in a number of issues. Let's talk about these different issues. Here, I've selected 5 very common questions which are associated with data lineage. The first one is very simple. It's where is this data coming from? I'm looking at a very important report. I see a sales figure which can decide whether folks from my department are going to be fired, for example. And I want to make sure that I have the right information. And for that, I need to understand where the data is coming from, if it's credible or not. Another type of question is who has access to this information? So that can be very relevant for legal and security concerns. I need to know, who has access to certain information. Third question: do we have sensitive data that's being propagated unsafely? Sometimes the data pipeline is so complex that sensitive data can end up in places which it's not supposed to exist, and then be disclosed in an unsafe way. Fourth question is my database still being used in an important company process, or can I remove it? Sometimes it's hard to know whether the database that's sitting in a data center is being used on a day-to-day basis. What relies on that? And we need data lineage to answer that question. 5th question: what systems and reports would be impacted by change in that particular process? So we have this process, this ETL process, for example, extracting data from a database and putting it in a data warehouse. What's going to happen if I change that process? I need to understand the particulars of the reports systems that rely on that process to be able to make a smart decision. So these are the top 5 data lineage questions that we hear from customers, and they can be very challenging for organizations who have not yet put in place effective data lineage initiative. The problem here is that traditional databases are not adapted to data lineage. First of all, they are hard to query. When you are working on data lineage, you need to understand the connections in your data. And querying connected data through SQL is a hard and error-prone process. Typically, it results in lines and lines of SQL code, and it's very hard to maintain and to get right. It's also very slow. As that kind of question requires multiple joins, it's going to result in slow performances. And finally, the SQL, the relational database approach, is very rigid. It's hard to accommodate an evolving data model in a relational database. So these are three very common challenges that companies out on the field have with data lineage. Companies that struggle with these challenges also have the different issues that I mentioned. So what's the consequence of that? The consequence are these. First of all, there's a general lack of confidence in data. I'm not sure where is the data coming from. I'm not sure if it's reliable. And then that impacts the ability to make informed decisions. That can also have result in potential legal exposure if data is being propagated unsafely. For example, that can be a very serious legal issue. And finding answers and making decisions become complex and time-consuming. I have to manually investigate, and it can take a lot of time. All of that results in wasted time, money, and opportunities. That's the exact opposite of being data-driven and agile. The good news is that there are new technologies out there, like Linkurious, that help organizations master the data lineage and be more data-driven. So let's talk a little bit about that. So first of all, GraphDBs are perfect for data lineage. Graph database is a database that stores data as a graph of nodes and edges. It's very easy to model the flow of data in a graph. It's very easy to query relationships and to do that in real time with a graph database. And a graph database typically allows you to adapt your schema to accommodate new data and relationships. So it's very, very flexible. And finally, the popularity of graph database has increased by 500% in the last 2 years. Partner Neo4j is the leader of that space. We see many companies relying on graph databases like Neo4j to launch effective data lineage initiatives. Linkurious brings to Neo4j, to graph databases, the ability to find answers and to turn the data into something that business folks, tech folks can access to find answers. Or visual interface helps users search the data lineage intuitively and find answers on their own. Visualization also brings the ability to understand and communicate complex connections. So it's not just about finding the answers. Sometimes it's also about, being able to explain a particular data lineage, something found in the graph, in a visual and effective manner. And finally, that newfound ability to find answers accelerate and improve decisions. So Neo4j and Linkurious are very complementary. With Neo4j, you can store a large graph and query it quickly. And with Linkurious, you can search it and find answers easily through a visual interface. So it's a very good match. Now I'd like to give you a demo of Linkurious and walk you through a concrete use case. So I'm going to switch tab and launch Linkurious. Here we are. So that's the interface of Linkurious Enterprise. And here I can see the one visualization I've created in the past. It's right here, and I can open it up by clicking on it if I want to. And I also have a search bar. Through that search bar, I can search my graph very easily without having to type any kind of code. So I'm going to search my graph, and I'm going to focus on a specific report. Let's say that I'm an IT analyst. Someone asked me, about that sales report that he is using, and he wants to know where is the data coming from. So I'm going to type total sales, and what I'm interested in here is a report. So I can see that the first result is total sales. It's exactly what I need, so I'm going to click on it and open it up. So let's zoom in, and we see that we are looking at a report that's right here, and it has a name which is total sales. So that's a single point in our graph, and we can see that it's connected to one particular object. So let's open up that relationship and see what is that specific object. So it's order total. I'm going to click on it. So now we have a metadata. So order total is a metadata. It has an ID here. It has a name, which is order total. And we are starting, to see where the data in the total sales report is coming from. At this point, I'd like to start, coloring the nodes based on that type. So we have a metadata node, we have a report node. I want to be able to distinguish between them. So I'm opening up the design panel, and I'm going to choose to associate a color with the category. And now I can, distinguish between the metadata and the report. If I want to, I can, go a step further, and perhaps I want, an icon with associated with the report. So I'm going with the report. So I'm going to click on report. I'm going to try to find something that makes sense as an icon for my report. Let's go with this. And that's it. Now we have an icon that represents the total sales report. But right now we are still, diving into that data lineage for the report. We have found one metadata, but we can see that this metadata has multiple connections, 7 of them to be precise. So I'm going to double click on the order total and see about these connections. So okay, now I see that I see more information. I see, for example, that the order total is connected to by a flows to relationship to the order status unfulfilled. It's connected by a flows to relationship to the total by employee ID, and it's connected to a stored-in relationship by the sales data warehouse, sales DW. So I can see that that particular metadata is linked to a few components of my system. I'm going to select these reports here, because what I'm interested in here is only the total sales reports, and I don't want to hear about these other reports which consume the order total metadata. So I'm going to select them and then hide them. And now they are hidden. And I can focus on the rest of the graph. So I can see that my order total here is stored in the sales data warehouse. And I can see that it's linked to some other stuff through, okay. And I can see that it's linked to some other stuff through a process. So I'm going to expand the process here. And now I can see that I have another metadata and this time I'm going to expand it. I can see that this particular metadata is linked to another system, which is the sales stage. So I can see that we have metadata which is which is stored in the sales staging system. Then it goes to this process, end up here, and is stored in the data warehouse and flows to the total sales report. And I can go one more step, further down the stream by double-clicking on this process here. I can see a new metadata, which is, still called order total. I'm going to click on it. I can see that it's stored in the sales DB. So here, there's no more stuff to expand, and I have the full data lineage of my total sales. So I started here. I identified that particular metadata, which through that process was linked to this metadata, which through that one process here is linked to this metadata, and I can see that that metadata is stored in the sales database, sales DB. So I have, the full picture. I can see that there are 3 systems which are involved in producing that total sales report. There's the sales database, the sales stage, and then the sales data warehouse. I get the full data lineage picture. I could also, change the question and start from particular system like a database and see everything that depends on it. And I'm going to show you how to do that. So first of all, I'm selecting all the elements in my graph. I'm going to hide them. And now let's focus on a database which we are calling the HR database. So I'm typing HR DB, get a result here, and I'm going to add it to my graph. I'm selecting it. It doesn't have much properties, just one, really, a name. And I'm going to double-click on the HR database to see what it stores and what kind of processes and ultimately reports depend on that database. So let's double-click. And we see that there are multiple metadata which are currently stored in our database. So we have country, city, manager ID, employee ID, first name, last name, yearly salary, street, position. That's it. So it's all metadata which is related to the HR context, and it's all stored in the same database. I'm going to select all my metadata, and I'm going to expand them and see to what they're connected to. So I'm click on expand here, and I can see that they're all connected to at least one process, to one process. Okay, interesting. Now let's select all the processes and see where these processes flows to, and they flow to another metadata. So let's zoom in to take a concrete example. We started with the HRDB, and we saw that there was a position metadata, which through a process is being transformed in a new metadata. If I click on that new metadata here, I can view that it's stored in the HR stage. Like it sounds a lot of the other metadata, and I can see that it's also connected to another process. I can keep on following that. So here we have another process, and we can see that we have another process here. We can see that it results in this position metadata, and we can see that the position metadata is stored in a HR data warehouse right here. And we can see that there are 8 other metadata which are being stored in the data warehouse, and we can see that there are 2 reports that depend on that particular metadata. One of them, this one, the payroll by position, seems, by the way, to depend on another metadata. And if I expand, I can see that it depends on the yearly salary. And I'm guessing here, yeah, I'm guessing that this metadata is linked to a metadata which was linked to the HR database. So if I zoom out a little bit, I can see that this particular payroll here depends on this position, on this metadata, which depends on this process, on this metadata, and finally on this HR stage. So it's a fairly complex lineage, and I'm able to follow it interactively with the demo, with the interface of Linkurious, to track down a chain of a dependency. And if I want, I can change the layout from to display the hierarchical structure here, and I'm going to choose to display things from left to right. And once again, I can take my payroll by position, and I can see what it relies on at this stage, at this stage, at this stage, and ultimately at this stage. So it's very easy for me, as someone who is not necessarily technical, to click my way to an answer through the interface of Linkurious. I can quickly find answers to my questions. So that's really what Linkurious enables. It's the ability to search data, visualize it, explore it, and find insights that would otherwise remain hidden to you. There are multiple benefits associated with using Linkurious for data lineage. First of all, it's very easy to deploy. Software architects can quickly provide a secure, customizable, and collaborative access to their organization's data. It's also faster to analyze data, and that benefits to business analysts who have a tool to find answers in complex data. That leads to better analysis and faster decisions. Finally, there's less risks for decision makers. They can get data-driven decisions without the risk and cost associated with the creation of a custom tool. So let me talk a little bit about the architecture and how it works. The most simple deployment case is Linkurious and Neo4j deployed on the same server, and then the end users simply type an address in their web browser to access Linkurious and can explore their data without having to install anything through their web browser. Of course, that can be more complex sometimes. We have customers who run ETL jobs to sync Neo4j databases with other systems, whether it is Hadoop, MySQL, or data warehouse, or something like Spark. And the data stored in Neo4j can be consumed by multiple applications. So that's it for today. So soon the video of the presentation will be online. If you have any questions about the webinar of today, or about data lineage in general, or want to talk about your project, please drop us email at contact@linkurious.us, I would be happy to get in touch with you and discuss the specifics of your project. Au revoir, everyone. Bye-bye.